So this is going to be video notes of how to tessellate. First starting with just regular shapes, and then if we want to make it more artistic and make some cool designs out of it, or pictures. Tessellate, we're going to start with quadrilaterals, and basically what does tessellate mean? It means all the shapes fit together without a gap in between them. And if you're talking about quadrilaterals, again a four-sided figure, you know what a quadrilateral is. All quadrilaterals tessellate no matter what. And the reason why all quadrilaterals tessellate is because if you take any four corners of a quadrilateral together, they'll add up to 360. Well, if you know 360 degrees is a full circle. So if you tessellated and put these side by side, and then put these side by side, if I can line them up straight, the four corners of a quadrilateral are going to all fit together with no gap in between them because of the, in this case, 90, 90, 90, 90 is 360 degrees. Any quadrilateral will work. Of course, there you see a rectangle, a square, a rectangle would do the same, and I could keep going and going with rectangles. A trapezoid. Trapezoid even works, but you got to be careful of how you do the trapezoid. You don't put them side by side like this. You put them side by side like this. So basically, as you tessellate a trapezoid, you have to rotate it so that when you're done, each of the four corners of the trapezoid meet together. So if this is corner 1, 2, 3, and 4, you have corner 1, corner 2, corner 3, and corner 4 all touching each other at the same time. And then you would just keep going from there. Even a parallelogram, not 90-degree angles, but you put those two together, and then put these two together, they'll tessellate. Oops. And here's a quadrilateral that doesn't have any characteristics whatsoever other than that it's four-sided. If you look at this, I went yellow, green, blue, and red so that you could see, okay, you can't put the red and the blue together, but if you put the blue and the yellow together, and rotate it the right way, oops, and then this one will go down and fit in here. And then this one doesn't look like there's any possible way it's going to fit, but if you rotate it, we get the red angle in there. Uh-oh. That's not good. It just separated on me. Slide that baby in there. And as you can see, the red, blue, yellow, and green all fit perfectly together. No gap, tessellates. And then you could keep going from there. Triangles. All and any and all triangles tessellate also. Why do they? Well, we already know triangle sum theorem that 3 angles of a triangle add up to 180 degrees. Well, 180 degrees is half of 360. We need a full 360 to get all the way around, which means we just need more triangles. I can put these two side by side like this, but then the next one, I'm going to have to flip it upside down. I'll put this one here, turn it upside down. So basically, it's going to take 6 triangles to tessellate and to fill in the gap. And I could put another one there. I won't take your time to have you watch this. Same thing here. I'm going to do these two, and then I'm going to do this one, and flip it over so it fits right in there, perfectly upside down. If we wanted to keep going, get a full 360, we would do 3 more triangles underneath it. So any and all triangles work. Isosceles triangles work. Right triangles work. This is a scalene triangle. Same idea. Get them side by side. Put the one in the middle upside down. Or mathematically, we would say reflect it or rotate it. And then we could keep going from there if we wanted to. Just keep spinning them and putting them together. Whoa. Missed. That would fit there, there, there. And the other one, hexagons, they will tessellate only if their opposite sides are congruent and parallel. And hexagons, 6-sided figures, so they do have opposite sides. These two opposite sides are congruent and they're parallel. These two opposite sides are congruent and parallel. Those two opposite sides are congruent and parallel. The reason we need that is because the left side of this hexagon has to meet up with the right side of that hexagon. So we could keep going across like this. Now when you do the next row, you can't just line them up. This does not count as a tessellation. You can't say, oh, I tessellated these hexagons with that quadrilateral in the middle. No, you've got to slide it over and offset them. Remember I said opposite sides are congruent and parallel. This side is opposite this side. So you have to slide it or translate it down that direction for it to fit in there. This one is a little bit more goofy shaped, but same idea. Opposite sides, congruent and parallel. What's opposite this side? You got to slide it over to get opposite this side. So some hexagons will tessellate, not all of them, not like a quadrilateral will. This one would look the same, opposite sides, congruent and parallel, and they would fit together like that. All right, so we're going to take our tessellating polygons and turn them into some art and make them cool, make a great design. We'll start with, there's more than 3 different methods. We're going to stick to 3 different methods, 2 of them very, very close to the same. A technique called modify and translate. When you modify and translate, that's exactly what you're going to do. You're going to modify your polygon and then translate that design over and over. If you're going to modify and translate, you need opposite sides congruent and parallel. So it would work on some hexagons. Any and all parallelogram, rectangles, squares, rhombuses will all work. Doesn't work on a triangle because a triangle doesn't have opposite sides. So it has to be an even-sided figure. Here I'm going to show you, I have all parallelograms, and I'm showing you the parallelogram, but it would be exactly the same on a rectangle, a square, a rhombus, would all be the same. So I modified this side, being careful not to dip down too deep. If you dip down too deep, more than halfway, then it's not going to overlap properly. And over here, notice I didn't go outside the realm of the actual parameters of the parallelogram. So I'm going to take this design, I modified this side, so basically I'm going to get rid of this parallelogram eventually. I modified it, and now I'm going to translate it and trace it again over here to this side. And then I'm going to trace it again to this side. So there's a translate, and also opposite sides congruent and parallel. I'm going to translate it down here, and I'm going to translate it over here. So when you make a shape, when you're doing your art, you don't actually make a design and then try to trace it over and over and over. Nope, you design one side and then trace that one side continuously so that your pattern stays true to form. And I could keep going, but I think you get the point of what this is going to look like. Take the exact same and just keep modifying it and translating it over to that side. Okay? Then you still have the 2 sides of the parallelogram. Be careful on your modification now. You can't go nuts and just make it anything you want because you don't want to run into your old pattern. So I'm going to modify this side just a little and make it, I don't know, maybe like this. So it kind of runs into its old translation, or its old modification, but then goes from there. And I'm going to take that same tracing and just keep going and going back here on every one. And when you're done, or if you do this right, you won't actually have the parallelograms in the background. And maybe I can get rid of those. I think I can. So without the parallelograms, you have that shape. Now you might look at that and be like, well, what is it? It's nothing. It's tessellating shape. Or somebody who has a little bit more artistic, creative ability than I do, they might look at that and say, oh, but if you colored this a little, you could put an eye in there, and that could be like a cardinal, and you can make that his beak, but then you want it to just be part of it, so you could do some drawing and coloring within it and make it something different. As you saw up here, I think one of them was like a fish and a bird, depending on how you looked at it. The shape was the same every time, but they colored it different. So that's a modify and translate that you can do on any type of quadrilateral that has opposite sides, congruent, and parallel. I'm only going to spend a second or two on this one. Okay, more than a second. But you could do it on a hexagon. It's a lot more complicated when you're making your project, but then you could also make a lot cooler project than a lot of other people. If you modify and translate on a hexagon, you have to modify 3 different sides. So you would modify this side, translate it down. Modify this side, translate it over. Modify this side, translate it there. And then you would continue, and remember your hexagon is going to continue kind of in a diagonal pattern. This green side would then match up with that green side. I won't be able to do it here, but what you would do is continue to trace the green, 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 and then this way go red, 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 and then fill in the blue, 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 and when you're done, you have the whole pattern. But it's a way of doing a hexagon if you want to make it a little bit more complicated, but you don't have to. All right, so I said there's going to be 3 different types of basic tessellations. This glide reflection is almost exactly the same as the translate. It just makes it a little bit cooler. You do still need opposite sides congruent and parallel, just like we said, so it worked great on parallelograms, rectangles, squares, rhombuses. And I'm not going to show you on a hexagon unless you need help with it. So I switched it to a rectangle instead of a parallelogram just to show you. Here's what's different about a glide reflection. It should be called a translate reflection. I don't know why they changed it to glide, but basically same idea. When you did this and you translated it over. Okay? What's different about a glide reflect rather than a translate is I'm going to take this and a translate, you would just keep going and going and going and going and going. I'm going to take this shape that I did right here, and if I'm holding it and tracing it, I'm basically going to reflect it or just flip it right over. So it's actually going the opposite direction. So then I want this to keep going this way. Okay, and then I come down to this row. This row is going to match my original first row. So every other row, you're going to flip over whatever it is that you're tracing to do it. Same thing with, let's say I'm going to modify this side. I'm just going to do this and make a little fishtail. Okay, so I'm going to take that guy and I'm going to make the same one over here and over here and over here. But if you want it to stay true to form and work down here, you're going to take this and flip it over itself also. Reflect it, you should say. Oops, it didn't flip. Flip, left to right. So now this is going to go this direction. And I'll clone it. And clone it. So as you can see what's happening up here, I missed one up here somehow, is you have the exact same design that we did before. When we did our translate, they all went the same direction. If you do a glide reflect, they're actually traveling, if they're traveling somewhere, in the opposite direction. And get rid of my rectangle there. So if I was gonna make a fish out of this, put a nose on it, put a mouth, give it some fins, whatever, okay? My fish are all swimming that way, but then when you come back this way, they're going the other way. So that's the only difference on a glide reflect. Do a row, reflect it, do a row, reflect it, do a row, reflect it. Kind of adds a cool little twist to the, a cool little reflect to the translate. All right. I think there was one of those in here maybe where they were going opposite directions. This one, the birds. The white birds are flying this way, the gray birds are flying that way. And it's nearly impossible to look up one of these on Google and just copy it and draw it. No, it's so much faster if you actually just draw a piece at a time and fill the whole paper. Lastly, full rotate. A full rotate, you must have all congruent sides and angles. Equilateral triangle, square, regular hexagon. Triangle, square, hexagon. Those are our only options for a full rotate. And they're gonna look a little bit different, depending on which one you do. I'm gonna start with the triangle. And because a triangle gets very narrow at the top or at each vertex, you can't make a super obnoxious big design because then when you rotate it, it's gonna fill in and it's gonna take up that space. So I just made a little design here, and what I'm gonna do is rotate it. So I'll pick this point, I'm gonna take this and I'm gonna spin it 100 and however many degrees, but I gotta make sure it lines up over here. So you're basically gonna grab your shape, trace it, hold it down at this point and spin it to the other point and do the same over there. Looks like Shrek, doesn't it? Okay, but when I rotate it again, it's now going to rotate in instead of out. You can't have them all rotate out, otherwise they're never going to fit together as triangles. So there's your full rotate. Now, triangle's a little tricky because a triangle has 3 sides to it instead of an even number. It has an odd number. So in this triangle, when 2 of those sides stick out and one of them goes into the triangle, the next triangle is going to do the exact opposite. So if you look at it, what it's going to do, actually I think I might have a picture of this, or you have it on a handout. Okay, so same idea. Here's my Shrek looking guy with his ears sticking out, and that one goes inside. But the next triangle, pardon that bell, you've got the 2 of them go inside and one of them goes outside. And then the next one, 2 of them are outside of the triangle, 1 is in. So you're going to have a skinny design and a fat design, even though your triangles were all the same size. They're all going to look the same. So there is a full rotate on a triangle. I'm not going to fill this whole thing out. You'll see what happens. But I'm also going to show you on a square and on a hexagon what they look like. Okay, so here's a full rotate on a square. Again, all sides have to be congruent, so you can't use a rectangle, parallelogram, rhombus. It has to be, well, maybe a rhombus would work. Oh no, all sides and angles have to be congruent. So, square. Again, make any kind of modification to one side. Take that same piece, grab it, and rotate it. Now, if you're looking at this square, this design sticks out of the square. So when you rotate it, it has to then come into the square. You're going to rotate it this direction. You don't want both sides sticking out. You want out, in, out, in. Then I'm going to rotate it again. Down here, as you can see, I can't stick into the square. You're going to rotate it so that it sticks out of the square. And then the last one is then going to go into the square. So you're going to have one piece, if you're doing a full rotate, that's exactly the same. You're never going to change it. All you're going to do is trace it, rotate, trace it, rotate, trace it, rotate, and it'll go out, in, out, in. Our triangle went out, in also, but because it's an odd number, you'll have 2 outs and an in, and then 2 ins and an out. And when I say in, I mean you're going into the triangle. So this is going to look like this. But now, keep in mind, you're rotating this square. This is what one of them looks like, but if I made this right next to it, it would never fit. It would leave a gap. So when you take this next one and rotate it, it's going to go, you're going to rotate it from here to in here. And if you can visualize this square, maybe I'll just clone it for you. This square is going to be next to it right here. Now, since this shape went out of this square, this one has to go in. Then this one has to go out. And then the next one has to go in. So when you're in a full rotate, your shape, even though it's the same shape, it's not facing the same direction. If I get rid of these squares back here, you can see exact same shape, but this one went up and down, and that one went left and right. Then the next one's gonna go up and down, and then left and right, and all you're doing is this one piece, and just cloning it. You guys will be tracing it by hand. You just spin it and trace it. Spin it and trace it. And it's just gonna keep going and going and maintain that pattern. You don't trace this whole entire thing and then try to copy that picture over and over. Trust me, it doesn't work. You lose it. They end up not fitting together. Because these you can fudge the corners just a little bit if you have to. So there is your full rotate with a square. I showed it to you already with a triangle. I could show you on a hexagon. I don't know. The hexagon fits together like this again, remember. You would just take one piece, and this is, again, if you want to get pretty intricate and creative in your design, your hexagon is going to go in, out, in, out, in, out, in, out. So it faced out, and then it went in. Then over here, it's going to go out, and then it's going to go in. Oops, that's the wrong way. No, that's right. In. And then it's going to go out. And then it's going to go in. So you'll just take the exact same design and just keep tracing it over and over, make sure it fits in your hexagon. And you could draw 3 different pit bulls out of that in your little circle if you want to. But that's what a hexagon would look like. I think this one, this lizard thing up in the corner probably was a hexagon. And something was modified and then rotated and then modified and then rotated all the way around. But that's it. You are going to be able to glide reflect, and I do have this handout for you. Can you modify and translate? Excuse me. Can you glide reflect? Meaning then they're going to go one direction, opposite direction. Or can you full rotate a triangle or a square, and I didn't put a hexagon on there. Good luck. I look forward to seeing the creativity.